Hi guys, today we're going to be talking about Cambridge A-Level Further Mathematics, October-November 2023, paper 4-2. It's a further probability and statistics paper. So we will start now. First question. A factory produces small bottles of natural spring water. Two different machines X and Y are used. A quality control engineer checks the volumes of the water in bottles and he chooses a random sample of 60 bottles filled by machine X. That means this is the number of samples for X. And a random sample of 75 bottles filled by machine Y. So this will be the number of samples for Y. The volumes of water X and Y respectively in millimeters are summarized as follows. So we have the sum of X, the sum of X minus X bar squared, the sum of Y, and sum of Y minus Y bar squared. So X bar and Y bar are the sample means of the volume of water. Find a 95% confidence interval for the difference between the mean volumes of water in bottles. So this is a question about confidence interval. Our first step would be finding the means and the S square, which is our estimate of the variance. Okay, so we have to find for X and Y. So let's find for X first. So the mean would just be the sum of X, 6345, minus the number of samples for X, which is 60. So we will get 105.75. And for the estimate of variance, we have the sum of X minus X bar squared over n minus 1 as our formula. So we have 243.8 over 59, and this would give us 1219 over 295. And for the mean of Y, we call it the Y bar, we have the sum of Y, which is 7614 over the number of samples for Y, which is 75. So this would give us 101.52. And for the estimate of variance of Y, we have the sum of Y minus Y bar squared over the number of sample minus 1. So we have 384.9 over 74. And this would give us 3849 over 740. So now we can start finding for the confidence interval. So for a 95% confidence interval, we call it CI. Let me draw the graph. So this would be the normal distribution graph, normal distribution. And this section here would be 95%, right? This would be our negative Z value and our Z value. So if you want to find for the Z value here, according to the formula booklet, we can see that we need to consider this entire area to find for this Z value. So we know that this area over here, this entire area, would be 97.5%. Alright? Because the whole graph is symmetrical and the area here equals to the area here. Okay, so now we know that we have to use 97.5%. So we can start doing. The formula for confidence interval would be x bar minus y bar plus minus the z value that we need to find later. Cert s squared for x over nx plus s squared for y over ny. So x bar, as what we found just now, is 105.75 minus y bar, which is 101.52, plus minus the z value. Now we have to refer to the table. 97.5% is 0.975, so the z value would be 1.960. So we have 1.960 and square root 1 over 60 times 1219 over 295 plus 1 over 75 times 3849 over 740. So now we write our confidence level in square brackets. So the first value would be this thing minus this thing over here. So we would get 3.50, and the second value would be this bracket plus this entire thing here. So we would get 4.96, and this would be the answer for our confidence interval. Question 2. The number of breakdowns on a particular section of road is recorded each day over a period of 90 days. So 90 would be the number of days. It's suggested that the number of breakdowns follows a Poisson distribution with mean 3.5. So 3.5 is our mean value. We call it lambda. The data is summarized in the table together with some of the expected frequencies resulting from the suggested Poisson distribution. So for part A, we need to complete the table. And for expected frequency, we have the formula as the probability times n, which is the number of days in this question. We have 90 days. So probability of Poisson distribution is given as e to the power of negative lambda times lambda to the power of x over x factorial. Alright? So for x equals to 3, let's call the expected frequency E3. So we have e to the power of negative 3.5, because 3.5 is our lambda over here, times 3.5 to the power of 3. 3 would be our x value over 3 factorial times number of days is 90. So the expected frequency for x equals to 3 would be 19.421. Let's round it to 3 decimal point because all their expected frequencies are in 3 decimal point. So let's follow this. So we have 19.421. And for the expected frequency when x equals to 6, we have e to the power of negative 3.5 times 3.5 to the power of 6 over 6 factorial times 90. So this would be 6.939. And we're done with part A. So for part B, carried out a goodness of fit test at 10% significance level to determine whether or not Poisson 3.5 is a good fit to the data. So we will need to carry out a chi-square test now. So first step would be our null hypothesis and our alternative hypothesis. So null hypothesis would be the Poisson distribution is a good fit to the data. An alternative hypothesis would definitely be the Poisson distribution is not a good fit to the data. Okay, now step 2. We need to have our values for O minus E squared over E. Okay, so we need to make a new table because when the expected frequency is less than 5, we will need to combine them together. So let's say for x equals to 0, our E value is 2.718, which is definitely less than 5. So we need to combine this value with this together. So after combining them, this will be more than 5, so we are good to go. And for 8 or more, when x equals to 8 or more, this is also less than 5, and x equals to 7 is also less than 5. So after combining, we have 5 point something. So this is more than 5, and we're also good to go. So our new table would have 1, 2, 3, 4, 5, 6, 7 rows. Alright, only 7 rows. So let me draw out the table. So we have the first column as the number of breakdowns per day. So we have 7 columns, 1, 2, 3, 4, 5, 6, 7, and the last column would be used for the total. Okay, so second column would be our O value, our observed frequency, sorry. Third column would be E, which is the expected frequency. And last column would be O minus E squared over E. Alright, so first row would be 0 and 1, which we can call it less than or equals to 1. Second would be 2, 3, 4, 5, 6, and for the last row, we have 7 and 8 or more. So when they mention 8 or more, we cannot just consider 7 and 8. We need to consider 7, 8, 9, 10, and so on. So this would be more than or equals to 7. For this one, let's call it 0 and 1. just to avoid confusion. So the last row, we need to conclude the total frequency. Okay, so now we can copy the data into this table. So for 0 and 1, the observed frequency would be 5, and the expected frequency would be 2.718 plus 9.512. So this would give us 12.23. And for number of breakdowns per day equals to 2, we have 13 and 16.646. So now we just have to copy all these values in according to the table. So for more than or equals to 7, the observed frequency would be 5 plus 4, and the expected frequency would be 3.469 plus 2.407. So this would give us 9 and 5.876. So if you sum all of them up, you would get 90 because that's the total number of days. And if you sum all this up, you would also get 90. So now we need to calculate these values. So we just need to calculate one by one. So O minus E squared over E. For the first row, we would get 4.27415. I like to round it to 5 decimal place because it's more accurate at the end when we sum all of them up. So yes. So for x equals to 2, we will have 0.79859. X equals to 3, it's 0.30180. And 0.94486, 1.41665, 0.61215, and lastly 1.66089. So now we sum all of this up, we would get 10.00909. So our test statistics would be 10.0 rounded to 3SF. And this is the third step, this would be the fourth step. So the fourth step, we need to find for the critical value. So our P would be 0.9 because they want us to test at 10% significance level. So 1 minus 0.1, we get 0.9. And for V, the degree of freedom, it would be the number of rows after combining minus the number of parameter estimated minus 1. So the number of rows after combining would be 1, 2, 3, 4, 5, 6, 7 minus the number of parameter estimated. Estimated means that the parameter wasn't given in the question and that we have to calculate it ourselves. So in this question, the mean value is already given, so we don't have to estimate it. So we don't have to minus anything for, sorry, for this section. And lastly, we just have to minus 1. So the degree of freedom would be 6. So now we refer to the table for the chi-square distribution. So V is 6 and P is 0.9. So we get 10.64 as our critical value. So chi-square equals to 10.64. So the fifth step, we have to make our decision. So 10.0 is less than 10.64. That means the test statistics is less than our critical value, and that's why we have to accept H naught, which is our null hypothesis. Step 6 would be our conclusion. So at 10% significance level, there is insufficient evidence to suggest that the distribution Poisson 3.5 is not a good fit to the data. So we accept H naught and we reject H1. Question 3. Toby has a bag which contains 6 red marbles. So we have 6 red ones and 3 green marbles. He randomly chooses 3 marbles from the bag without replacement. The random variable x is the number of red marbles that Toby obtains. Find the probability generating function of x. So in total, we have 9 marbles. And he chooses 3 from the bag without replacement. So we can draw out the probability distribution table. So since he only chooses 3 marbles from the bag, and we have 3 green marbles and 6 red marbles, so the number of possible red marbles that he can obtain would be 0, 1, 2, and 3. So let's find for the probability one by one. So for x equals to 0, that would mean he obtains 3 green marbles and 0 red marbles. So we can use the combination method. So 6c0 times 3c3 over 9c3. 9c3 is the total combinations that he can have, and 6c0 is because he has no red marbles, and 3c3 would be picking all 3 green marbles possible. Yes. So this would give us 1 over 84. And for x equals to 1, that means he gets one red marble and two green marbles. So we have 61 times 3c2 over 9c3. So this would be 3 over 14. And for x equals to 2, that means he has 2 red marbles and 3 green marbles. So 6c2 times 3c1 over 9c3 equals 15 over 28. For x equals to 3, that means he gets 3 red marbles and no green marbles. So 6c3 times 3c0 over 9c3. This would be 5 over 21. Okay, so now for the probability generating function, it would be the sum of t to the power of x times the probability of getting x. So the first value would be t to the power of 0 times 1 over 84. So t to the power of 0 would just be 1, so we have 1 over 84. Plus, the second term would be 3 over 14 times t to the power of 1, which is 3 over 14t. Third term would be 15 over 28 times t to the power of 2, which we have 15 over 28 t squared. Last term would be 5 over 21 times t to the power of 3. So we have 5 over 21 t cubed. And this would be the answer for our probability generating function of x. Part B. Ling also has a bag which contains 6 red marbles and 3 green marbles. He randomly chooses 2 marbles from his bag without replacement. The random variable y is the number of red marbles that Ling obtains. It's given that the probability generating function of y is 1 over 12 times 1 plus 60 plus 5t squared. So the random variable z is the total number of red marbles that Toby and Ling obtain. Find the probability generating function of z, expressing your answer as a polynomial in t. So we know that z is equals to x plus y. And x and y are independent of each other. That means they don't affect each other's results. So we have the probability generating function of z equals to the probability generating function of x times the probability generating function of y. So this would be, okay, since they factorize the fraction out, right? We can do the same thing to this expression to make our lives easier when we multiply them together. So we can write gxt as 1 over 84 times 1 plus 18t plus 45t squared plus 20t cubed. Okay, so this times 1 over 12 times 1 plus 60 plus 5t squared. So now we just need to multiply these two expressions together. So we can multiply the constants and we would get 1 over 1008. And now we times these two brackets together. So we have 1 plus 6 plus 18t plus 5 plus 108 plus 45t squared plus 90 plus 270 plus 20t cubed plus 225 plus 120 t to the 4, lastly plus 100 t to the 5. So now I just simplify the bracket. So we have 1 over 1008 times 1 plus 24t plus 158t squared plus 380t cubed plus 345t to the 4 plus 100t to the 5. And since they want us to write our answer as a polynomial in t, we need to times this fraction into each of the term. Alright? So we have 1 over 1008 plus 1 over 42t plus 79 over 504t squared plus 95 over 252t cubed plus 115 over 336t to the 4 plus 25 over 252t to the 5. So this would be the complete answer for the probability generating function of Z. Part C. Use the probability generating function of Z to find for the variance of Z. So the formula for variance would be G prime 1 plus G prime prime 1 minus the square of G prime 1. So how do we find for G prime 1 and G prime prime 1? We first need to differentiate G, and after finding for G prime, we differentiate G prime to get G prime prime. So G prime is what we found in part B. This whole expression over here. Let me copy it. So now we just differentiate this expression. So now G prime T would be 1 over 42 plus 79 over 252 T plus 95 over 84 T squared plus 115 over 84 T cubed plus 125 over 252 T to the 4. And to find for G prime prime Z, g prime prime of z, we differentiate this expression again. So we have 79 over 252 plus 95 over 42t plus 115 over 28t squared plus 125 over 63t cubed. So now g prime 1, basically we sub t equals to 1 into this equation over here. So we have 1 over 42 plus 79 over 252 plus 95 over 84 plus 115 over 84 plus 125 over 252. So the sum of this would be 10 over 3. And for g prime prime 1, we sub t equals to 1 into this expression. So we have 79 over 252 plus 95 over 42 plus 115 over 28 plus 125 over 63. So this would give us 26 over 3. And lastly, our variance would be 10 over 3 plus 26 over 3 minus 10 over 3 squared. So this would be 8 over 9. Question 4. The diagram shows the continuous random variable x with probability density function f. So these two are the function f, and a, b, c are constants. The upper quartile of x is equals to 4. That means, okay, the probability from the upper quartile to the last number, which is 6 over here, the probability would be 1 over 4, right? So when they mention that the upper quartile is equals to 4, that means the probability from 4 to 6 would be 1 over 4. Alright? So for part A, we have to show that C is 1 over 8 and find the values of A and B. So we can use this information over here. So to find the probability, we have to integrate this function. We integrate this function. So the integration from 4 to 6 of C would be 1 over 4. So the integration of C would be Cx from 4 to 6 equals to 1 over 4, and 6C minus 4C equals to 1 over 4, 2C equals to 1 over 4, and C would be equal to 1 over 8. And now we need to find the values of A and B. So for this point, we call it F4, and we can see that when we sub 4 into this function, we get F4, right? And when we sub 4 into this function, we get F4 as well. That means when x equals to 4, this function would be equal to this function. So 1 over 128 times 4a times 4 minus b times 4 cubed would be equal to c, which is 1 over 8. Alright, so now we can just simplify it. We have 16a minus 64b equals to 16. So a minus 4b equal to 1. This would be our first equation. And another information would be, since we know that this area over here is 1 over 4, so the area under this graph would now be 3 over 4, right? So the integration from 0 to 4 of the equation 1 over 128 times 4ax minus bx cubed would be 3 over 4. So now we integrate this. We have 1 over 128 times 2ax squared minus 1 over 4bx to the 4 equals to 3 over 4, and we sub in the values into the x. So we have 2a times 4 squared minus 1 over 4b times 4 to the 4 equals to 96, because I move this to the right side. So now we have 32a minus 64b equals to 96. So a minus 2b equal to 3. And this would be our second equation. So now we take the first equation minus the second equation. We would have negative 2b equals to negative 2. So b equals to 1. And now we find for the value of a. So a equals to a minus 2b, which is 2 times 1, equals to 3. So a would be 5. Part B. Find the exact value of the median of x. So we know that the probability from 0 to the median would be 1 over 2. And we know that the probability over here is 3 over 4. So 1 over 2 is maybe somewhere over here, right? So the median would be around here, which is in this interval. So we just have to integrate from 0 to m, the median, to find for the value. So we can integrate this 1 over 128 from 0 to m, 20x minus x cubed equals to 1 over 2. Why do I get this expression? We have found the value of a and b in part A, so I just sub it into this expression over here. So I have 1 over 128 times 10x squared minus 1 over 4x to the 4 equals to 1 over 2. So now I sub the value m into x. So I have 10m squared minus 1 over 4m to the 4 equals to 64. Rearrange the equation. I would have 1 over 4m to the 4 minus 10m squared plus 64 equals to 0. So I multiply the whole equation by 4. So I have m to the 4 minus 40m squared plus 256 equals to 0. Factorize this equation. I would have m squared minus 32 and m squared minus 8 equals to 0. M squared would be 32 and m squared would be 8. So m is plus minus 4 sub 2, which we would reject both of them because positive 4 sub 2 has way past this interval over here, and negative 4 sub 2 is not even in this expression. It's not even in the domain. So I reject both of them, and now m equals to plus minus 2 sub 2. So the final answer would be m equals to 2 sub 2. Negative 2 sub 2 would be rejected because it's not in the interval. So the median of x would be 2 sub 2. Part C. Find the expected value of sub x, giving your answer correct to 2 decimal places. So how do we find for this? The expected value of sub x would be integration of sub x times fx. Okay, which in this case, we have two different expressions for different intervals. So we need to multiply sub x into the first expression and integrate it with this interval, and multiply sub x into the second expression and integrate it with this interval. So we have 1 over 1 to 8 times the integration of 20x to the power of 3 over 2 minus x to the 7 over 2 plus the integration from 4 to 6 of x x to the power of 1 over 2. So now I can start integrating. 1 over 1 to 8 times 8x to the 5 over 2 minus 2 over 9 times x to the 9 over 2 from 0 to 4 plus 1 over 8 times 2 over 3x to the 3 over 2 from 4 to 6. So now 1 over 1 to 8 multiply 8 times 4 to the 5 over 2 minus 2 over 9 times 4 to the 9 over 2. When we sub 0 into x, we get 0 as well, so we can ignore that. So plus 1 over 8 times 2 over 3 times 6 to the 3 over 2 minus 2 over 3 times 4 to the 3 over 2. right? So we type it into the calculator since they want it in two decimal places. We don't need to find for the exact value, so we can type it into the calculator and we would get 1.67. Question 5. A company is deciding which of two machines, X and Y, can make a certain type of electrical component more quickly. The times taken in minutes to make one component of this type are recorded for a random sample of 8 components made by machine X. So 8 would be the number of samples for X, and a random sample of 9 components made by machine Y. So 9 would be the number of samples for Y. These times are as follows. The manager claims that on average, the time taken by machine X is less than the time taken by machine Y. Okay, so carry out a Wilcoxon rank sum test at 5% significance level to test whether the manager's claim is supported by the data. So this would be a Wilcoxon rank sum test. And okay, so first step, we have our H0 and H1. So H0 would be the median of X equals to the median of Y. And H1 would be the manager's claim, which is MX is less than MY. Okay, so step 2, we need to find for the test statistics. So we need to first find out for M and N. So M would be the smaller sample size, which is 8, and N would be 9, which is the larger sample size. So now we need to rank the data over here. So we need a table with 4 columns. First column for X. Okay, so we have 9 data for Y. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9. And another one for the total. So we need 4 columns. First one for X, second one for the ranking of X, third one for Y, and the last one for the ranking of Y. Okay. And the last row would be the sum of the ranking. So now we copy the data. So I copy this whole thing and I put it here. And for Y, I would put it here. Alright? 4.0, 4.6, 4.7, 4.8, 5.0, 5.2, 5.6, 5.8. Alright, and for Y, we have 4.5, 4.9, 5.1, 5.3, 5.4, 5.7, 5.9, 6.3, and 6.4. So now we can start ranking. So we look through all the data here and we rank them together. Like we don't rank the data according to X and Y, but we just compare all the data together. So the first one would be 4.0, second one would be 4.5, third one is 4.6, fourth one is 4.7, 4.8, 4.9, 5.0, 5.1, 5.2, 5.3, 5.4, 5.6, 5.7, 5.8, 5.9, 6.3, and lastly 6.4. So now we sum all this together and we would get 55. And when we sum all this together, we would get 98. So now Rm would be the sum of all the ranks of the smaller sample. So it would be 55 because this X has a smaller sample size, right? So 55 would be the ranks. And R prime M is given as M times N plus M plus 1 minus Rm. So we have 8 times 9 plus 8 plus 1 minus 55. And this would give us 89. So the formula booklet states that W is the smaller of Rm and R prime M. So the test statistics W would be 55. Okay, this would be the test statistics. And third step, we will need to find for the critical value. So this is a one-tilt test. And let's refer to the formula booklet. We have M as 8 and N as 9. So it's a one-tilt test and the significance level would be 5%. So it's 0.05. So we have our critical value would be 54. Alright, so the critical value W would be 54. So the fourth step, we compare the test statistics and the critical value. So test statistics is 55 and that's larger than 54. So we accept H0. Alright, so the fifth step would be our conclusion. At 5% significance level, there is insufficient evidence to support the manager's claim. And we're done. Part B. Assuming that the times taken to produce the components by the two machines are normally distributed with equal variance, carry out a t-test at 5% significance level to test whether the manager's claim is supported by the data. So now we need to do a t-test instead. So same thing. First step, we would need our null hypothesis and alternative hypothesis. So the null hypothesis would now be the mean of x is equal to the mean of y. And the null hypothesis would be the mean of x is less than the mean of y. Second step, we need to find for the critical value. So the significance level is 5% and it's a one-tail test. So our P would be 0.95 and V would be the number of sample for X plus the number of sample for Y minus 2. So V would be 15. So now we need to find for the t value using the formula booklet. So V is 15 and P is 0.95. So we have our t value would be 1.753. 1.753. But because this is the symbol less than shows that we would be finding for the left tail of the normal distribution graph. So our t value should be a negative value. So third step, we need to find for the test statistics. So we would first need to find the sum of x squared, the sum of y, and the sum of y squared. So for sum of x, we just add all these data together. So we would get 39.7. And for the sum of x squared, we square each of the numbers and we add all of them together. So we would get 199.33. And for y, we do the same thing for the values of the y sample. So we have 49.5 and 275.47. Okay, so now we need to find for the mean of x and the mean of y. So the mean of x would be 39.7 divided by the number of sample for x, which is 8. So this would give us 4.9625. And the sample mean of y would be 49.5 divided by 9. So we would get 5.5. So we also need to find for the pool variance because we assume that the two machines have equal variance. So we need to find for the pool variance. So the formula for pool variance would be the sum of x squared minus the square of sum of x divided by the number of sample of x plus the sum of y squared minus the square of the sum of y over the number of sample for y over number of sample of x plus number of sample of y minus 2. So this would be 199.33 minus 39.7 squared over 8 plus 275.47 minus 49.5 squared over 9 divided by 8 plus 9 minus 2. So our pool variance would be 0.36925. And now we can find for the test statistics T. So the formula for T would be sample mean of x minus the sample mean of y divided by the square root of pool variance times 1 over nx plus 1 over ny. And we can start subbing in the values. So for sample mean of x, we have 4.9625, and sample mean of y is 5.5 divided by the square root of the pool variance, which is 0.36925 times 1 over 8 plus 1 over 9. So this would give us negative 1.82, rounded to 3 significant figure. So the fourth step, we compare the test statistics and the critical value. So negative 1.82 is less than negative 1.753. So we draw the left side of the graph, and we can see that if this is negative 1.753, this would be the rejection region. And this would be the acceptance region. And we can see that negative 1.82 lies over here. This would be negative 1.82. And this definitely lies in the rejection region. So we would need to reject H0. So the last step would be our conclusion. So at 5% significance level, there is sufficient evidence to support the manager's claim. And we're done. Moving on to part C. The question asks, in general, would you expect the conclusions from the tests in part A and B to be the same? Give a reason for your answer. So part A is a non-parametric test, and we rely on the median of the sample instead of the mean. And in part B, we rely on the mean. So the difference between median and mean is that if there's an outlier in the sample, the outlier would affect the test that uses the mean value because outlier affects the mean value but not the median. So we can say that because they want it in general, right? So we don't really have to mention about the test itself. We don't have to mention the question given to us. So we can say that the outliers in data would affect the t-test, but not the Wilcoxon rank sum test. So the results will be expected to be different. Or we can say the results will not be expected to be the same. And we're done with this paper.